Morning, sir.
Oh, hi Bob. So today we're gonna talk about solving differential equation using annihilator method. So to solve this, we need to set up annihilator operator, which is in terms of d. So Bob, do you know how to set up these annihilator operators?
I know.
For the equation y double prime plus y prime plus y equals 0, we will have to change it to d squared plus d plus 1 equals 0. For other operators, such as the unknown x, if x is to the power of n, it will become d to the power of n plus 1. Such as x will become d squared and x squared plus 4 will become d cubed. As for e to the power of nx, it will become d minus n. So for example, we can see that e to the power of 2x will become d minus 2, and e to the power of negative 4x will become d plus 4. And for our trigonometric function, sine nx will become d squared plus n squared. This applies to our cos function also. Cos nx will also become d squared plus n squared. For example, sine 4x becomes d squared plus 16, or d squared plus 4 squared, and cos 5x becomes d squared plus 5 squared, or d squared plus 25.
Well done, Bob. Let's move on to the example.
Example 1. Y double prime plus y prime plus 1 over 4y equals to x times e to the power of x. For y double prime plus y prime plus 1 over 4y, the annihilator operator should be d squared plus d plus 1 over 4. And when we solve for the value of d, both of the value of d are negative 1 over 4 and negative 1 over 4. Both are the same. On the right side of the equation, the annihilator operator for x times e to the power of x should be bracket d minus 1 to the power of 2. And both of the value of the d also the same. Both are 1.
Question.
Why is x e to the power of x not set up as d squared times d minus 1? If it's so, then our solution of d will become 0, 0, 1.
No, Bob. The annihilator operator of the question should be set up as d minus 1 to the power of 2. That's because the y particular, yp of the question is x times e to the power of x, not x plus e to the power of x.
Oh, okay. I see. I understand now.
Alright, let's continue solving the example. After we got the values for d, we will substitute those values into the auxiliary equation. In this case, the values of d are repeating, so we will set up our equation as y equals to c1 e to the power of negative 1 over 2x plus c2 x times e to the power of negative 1 over 2x plus c3 e to the power of x plus c4 x times e to the power of x. c1 e to the power of negative 1 over 2x plus c2 x times e to the power of negative 1 over 2x is our yc. c3 ex plus c4 x times e to the power of x is our yp. This is not our final answer yet. We need to solve for yp for c3 and c4. For that, we need to differentiate yp. When differentiating c3 e to the power of x, c3 is a constant, and differentiating e to the power of x will result in e to the power of x also. So the answer will be c3 e to the power of x. But for this c4 x e to the power of x, there's two variables x and e to the power of x. So product rule is applied to this. So when you are differentiating x, will result in 1, so we will get the c4 e to the power of x. But when we differentiate ex, the answer will be also ex. So we will get c4x to e power of x. And the same for this. To get y double prime p, we still need to differentiate c4x e to the power of x. And product rule is still need to be applied on this. And you will get the same answer as in the y prime p. So the y double prime p will be c3 e to the power of x plus c4 e to the power of x plus c4 ex plus c4x e to the power of x. After we get yp, y prime p, and y double prime p, we will substitute them into original equation, and we will get this equation. The variables in this bracket is y double prime p, in this bracket is y prime p, while in this bracket is yp. After rearranging this equation and factorizing out the common ex, we will get this simplified equation. Next, we will compare the left side of the equation to the right side of the equation. As we can see, the right side of the equation does not have the variable ex, so we will equate 9/4c3 plus 3c4 equals to 0. But for variable x, e to the power of x, the right side of the equation has the variable 2, and the constant in front of it is 1. So we will equate 9/4c4 equals to 1, and when we solve it, c4 equals to 4/9. To solve for c3, we will substitute this value of c4 into this equation. And after we solve it, c3, we will get the c3 equals to negative 16/27. Lastly, we will substitute c3 and c4 back into the auxiliary equation. So for the answer, we will get y equals to c1 e to the power of negative 1/2x plus c2 x times e to the power of negative 1/2x minus 16/27 e to the power of x plus 4/9 x times e to the power of x.
Thank you, sir. Now I can score DE.